Hi, this is Satish from Group 9 and I will be demonstrating the operation of VPN in our network topology. So as per the requirements, we have set up IPsec tunnels going from Perth router to Adelaide headquarter router right here, and then again Queensland router to Adelaide headquarter router. By doing so, we have masked the IPs coming from corporate networks of Perth and Queensland so that the ISP is not able to access the actual corporate networks. To demonstrate, I will be pinging from this workstation in Perth, which has IP of 192.168.111, to Adelaide headquarter workstation, which has IP of 192.160.911, where 9 is our group number. Okay. We were in simulation mode now. As you can see, the ping is going through and there were no packets that were dropped. And now if we do a trace route of the same ping, we should be able to see that the ping goes from the workstation itself, and instead of going through the Perth router IP and then to ISP IP and then to Adelaide gateway, it goes straight from the workstation to Adelaide outside IP and then straight to the workstation itself in Adelaide, which shows that the VPN is indeed working. And now for Queensland, I'll be pinging from this workstation with IP 192.168.2.11 this time to the same headquarter workstation 192.160.9.11. So if we do a ping, no packets dropped. Trace route of the same ping, we should be able to see similar results. And yes, the ping goes from the workstation and then to Adelaide outside IP and then to the Adelaide workstation. To further prove that the VPN is indeed set up correctly, we can also do a simulation of a packet going from this workstation to this workstation. And then capturing the packet right at the ISP. We can see that the source IP is hidden. Instead, the outside IP of the Perth router is given instead of being 192.168.1.11. And the destination IP is hidden as well, or masked, I should say. We can also see the ESP encapsulation and encryption being implemented here, which clearly shows that the tunnel is set up correctly. Now, as per the requirements, we were also told to set up a remote access so that any employee can access the corporate network on the fly. For that purpose, we have set up a DSL modem connection going from ISP to a remote out of premise area. So this is an entirely different network, and as you can see, this network is 10.0.0.0 and this workstation has IP of 10.0.0.2. So from here we have set up a remote access VPN with the credentials. We should be able to log into our VPN client, which is in this case the Adelaide router, the headquarter router. So remote. So the Adelaide headquarter outside IP is 209.9.165.1.1. Username is remote user. Password is MIT183077, which also happens to be my student ID. Now to hit connect. And as you can see, the VPN is connected. Now it has the client IP of 192.160.9.151, which falls under the network of Adelaide headquarter 192.160.90, and we should also be able to see it in IP config. As you can see, it has tunnel interface of 192.160.9.151, and if we ping from this workstation to Adelaide workstation, the ping is indeed successful. And if we do a trace route, one nine two one six zero nine 11, and there are only two IPs involved. First one being the Adelaide outside IP, similar to what we did before, and then to the workstation, so none of the ISP or any other IPs involved in this trace route, which proves that the remote VPN is set up correctly as well. And that is it for VPN setup. Thank you.
Hi, this is Iswa Cody, one of the group members of BN305 Assignment 2, is building a VPN network between three different branches of a company. So the left-hand side is Perth, the middle one is Adelaide, the headquarter in blue, and then the right-hand side is Queensland. So I'm here to talk about how we set up our DHCP server for all these networks, and also the wireless LAN controllers through the Radius servers. Alright, so let's get started on it. So the left hand side, I can see that there are like five different departments, and all of them are configured through DHCP server, which is here. And if you go to DHCP, we should see the server pool running. So it says the IP should start from 1.50, 192.168.1.50, and the default gateway for the server pool is the address of the router itself, which is this router here and this interface. Alright, so let's have a look at the DHCP server running and try and get an IP from the DHCP pool. So it's on static at the moment. So if I do DHCP and request the IP address, it might take a few moments. Let me fast forward it, and then should have the IP now. Yep, so we have the IP address, which is 1.54. So we said that it will start from 1.50, so it's all good that it's at 1.54. And the gateway is 192.168.1.1, so which is basically the same, but the IP pool of the network will be different by the other one. So let's try and get DHCP IP from the DHCP server from the Queensland, sorry. So yep, if I go to DHCP and then request an IP address, which I will fast forward as well. I should get 2.154, which is also the over the starting IP, which is 2.150 for the DHCP pool created on the server for the Queensland network, which we can see over here. Start from 2.150. Alright, so that's the DHCP server and how we created it. Let's talk about the wireless LAN controller, which provides the access to the lightweight access points to give the wireless connection for all the departments or all the branches. Okay, so for the wireless LAN controllers, we've set up a radius servers for all the departments or all the branches, which we can see in AAA, which is this. So this is the radius server for the LAN that is created in the Perth network, and we can also see the username and password required to log into the or required to connect to the lightweight access point from any of the wireless supporting devices. So, and if we have a look, PC wireless connect, refresh, we should see the available lightweight access point for the company. I know it's not shown, but so we have the lightweight access point here, which got the IP address from the DHCP pool itself as well, which is DHCP default gateway, and it gets the IP address from the DHCP pool, which connects the PC. Alright, so let's try and ping the devices from one network to the other, and also the departments. So if I try and ping from HR department to the HR department from the other branch, we should be successful. Or we can do it the other way as well. So the IP address is 2.11, and it's okay. So let's try and ping. So ping 192.168.2.1. Yep, so we got the reply from this PC, which concludes that the pinging is successful and the setup is successful as well. So I would like to pass it over to Senon for the other explanations. Thank you.
Thank you. So now I'll be talking about our physical design of the network. So as you can see, we have three branches: Queensland, Adelaide, and Perth. And in here, you can see this is our corporate office. And in here, you can see the wiring closet and all the devices that are connected to it. And once you click here, you can see all the devices that are connected to the main server. So the switches and access point. And we have placed access point in the middle to make sure that it covers all the devices that are connected to it. And the rest of the branches have the same layout as well. And the out of premises means it's for those who are not located in any of those branches, and if they want to access the network, they can do from any location securely, and we provided a cloud VPN for them to make sure that wherever they connect from is secure and there are no breaches of any source. So this is our physical design. Now I'll be passing on to Sewang to describe the rest of the configuration. Thank you.
Thank you, Senon. Hi, my name is Sewang Dendu, student ID MIT 182692, and today I'm going to demonstrate and show you the remote connection that we have set up for our network design. As the previous members have clearly defined and explained about the various branches and the various network design that we had for the other sites. There's a requirement that is specified in which remote user should be able to access the company's network. So as you can see, we have isolated this part of the network which is accessible for remote users. So the remote users can use their laptops to access the company website. They can get connected to any access points in their physical location, in which this access point is then connected to the DSL modem, and then this DSL modem will carry the network request to the cloud PT, which is basically the internet, as remote users do not have the actual capacity to access the company network without the help of internet. So the internet, they can just transfer the request through the internet, and this request will go straightly towards the ISP router, and which will then connect through all the routers in the 3 branches. That is the main branch in Adelaide, the 2 branches in Perth and Queensland. So basically, what this design will allow is the remote users to get access, and they can access the company's network. So I'll just show you the pinging between the laptop and the ISP router. As you can see here, the laptop from the remote user is able to ping with the ISP router, and this ISP router will then ping to the other routers in which the remote user wants to access the network based on their requirements wherever they are. Thank you, and I would like to pass it on to the next presenter.
Thanks, Shivang. So I am Harpreet Kaur, and now I will discuss about the routing protocol that we use in our network design in order to make sure that all the devices in one network can communicate with devices in other network. For example, like all the devices in Perth can communicate with devices in Adelaide and Queensland. So in order to make this, we need routing information protocol is like all the routers are sharing a common network so that they can communicate with each other. So if we go to the router in Perth, we can see that the interface is having the IP address 192.168.1.1, and the serial interface is having the IP address 209.165.100.1. So this the fast Ethernet, this is the IP, this is the gateway, or this is the gateway for all the devices in Perth department, all the devices in Perth, and this is the address that is used as a common address for all the routers. So if we go to the RIP, here we can manually add the networks that we want to add. By this way, we can just put the IP address like 192.168.9.0, and then we can just click add, and we can add the network in this way. So now if we go to the router in Adelaide, here we can see that the interface is having the IP address 192.160.9.1, and this is the network, this is the IP address which is shared from router to the ISP. And this is the network from router. This is the default gateway for all the devices in Adelaide. And here we can see that both the networks are added in the RRP. Now we'll go to the Queensland department. Here we can see the router. Here we can see the router is shared. The router is having the IP address this, and we can do it in the CLI mode as well. We can configure the RIP protocol in CLI. For this, the command that we need to run is, we need to run the command in the configuration mode. So router RIP. Then I can just fill up the network, that is the network in like that from the fast Ethernet 0/1, which was 198. Okay. So this way I'm adding the networks. And the other network is .165. So in this way, we can add the networks in CLI mode. I'll just go out. I think the networks are ready. So we can see the running protocol by Shoran. So here we can see that the router RIP is configured for these two networks. So by this way, we can make sure that all the devices in this department can communicate here. So let's try this. So from Perth to Queensland. It might will take some time. I'll try it from here to here. Yeah, so let's try to check the communication. So we'll try from sending message from Perth to like NAPC in Queensland. That's successful. And now we can try to any other PC or something, like here to here. That's successful as well. So now we'll try sending from router to anything like to here. Yes. So here we can see the communication is successful in all the departments, that is by the RIP protocol. That's it about the routing protocol. Thanks for listening.